Sir, good afternoon, sir.
Good afternoon. Am I visible to all of you?
Sir, can you please? Sir, I didn't hear your voice. Hello?
Hello. Am I audible to all of you?
Yes, sir. Yes, sir. You are audible and you are visible.
Okay.
Okay,
Just-
sir. Good afternoon, participants. Sir, you please take out the session, sir. Hello?
Yeah, please. Just 1 minute, 1 second. I am just coming to you. Yeah. Shall I share my screen now?
Yes, sir. You please share the screen.
Okay, please. Yeah. Is it visible to all of you?
Yes, sir. It's visible.
Okay. Okay. I'm ready. Is there any? Shall I start or?
Yes, sir. You please start.
Okay. So good afternoon to all of you. This is Dr. Swami Tari from Department of Electronics and Communication Engineering, NIT Rourkela. I have already given my first lecture where I have particularly shown that deep learning, and we concentrated the deep learning, though I have differentiated the deep learning and machine learning. And after that, I have shown some application on deep learning. Now, today's lecture will be concentrated on the application on deep learning technique, particularly for image and video processing. Okay. So for the today's lecture, we'll see that what are the different applications of deep learning. There are a lot of applications can be done, but we'll concentrate here to different applications and varieties of way of application of deep learning, which is a part of the machine learning techniques. Okay. So here we'll show some example of the image and video processing. Similarly, you can apply in your own applications. Okay. Let's start our next things. What is topics to be covered? If you look at, there are the three different. If I discriminate that the whole application in most of the real world application, there are three different types of signals we can apply, which is 1D signal, which is generally known as the signal, and we can apply the 2D signal, which is generally known as the image, for 3D signal, which is generally known as the video processing. Okay. So 1D means one-dimensional signal, 2D means two-dimensional, similarly for 3D means three-dimensional signals. So in the last class, we have shown the BCI BCI based brain-computer interface based EEG signal analysis. So already discussed in the last class. And also we have seen that the Glacier Lake outburst floods, how to predict that Glacier Lake's outburst floods using the image analysis or using the application of deep learning techniques or machine learning techniques. We have already seen it. Now today's class will concentrate, today's lecture will concentrate the hand gesture recognition as well as the human action recognition. We will show that here the varieties of way of application of deep learning for the specific purpose. Okay, let us proceed for the next one. So here, application of deep learning on image processing we will look on here. Now, in the application of deep learning on image processing, particularly we come here, we will show two different applications. One is that human gesture recognition, another is the action recognition. Now, if you look at that diagram, here the different hand gestures are given. I am showing your hand gesture, but this is also applicable for other gestures also. So here particularly we will concentrate our work on the character recognition purpose. Okay, so A to Z, otherwise also the numeric characters. So look, we in our lab, all the things whatever we are showing here, all the results from our pattern recognition and machine intelligence laboratory output, generated output. All the things are done are the research output. What we have, what the result received from our laboratory experiment. We can see here that different gesture A to J, but we have applied for all 36 gesture, 26 plus of 10 digit recognition. And this is the in front of the camera, one person's given the gesture. Look that the different type of gestures are only shown that A to J type of gesture, but a lot of gestures we have applied. And this is shown as here, when I click the capture the image, after this is the clicking on this captured, image captured, and after the recognition it's shown the D. D is the corresponding gesture. Now question is that by giving that gesture, how we can recognize it. So before that, before going to more in depth in the gesture recognition or a procedure, we'll see that what are the different application of gesture. What is gesture recognition? First we'll see, and then we'll see what are the different applications. If you look that gestures is the nothing but a human computer interaction system. Okay, so when we say want to share something to the computer, and computer will process accordingly or respond accordingly, that the whole system is called the human computer interaction, or human alternative and augmented communication, or HAC. So these are the human computer interaction or HAC are our daily lives is requirement for our daily lives purpose. So gesture is nothing but a expressive of poses, body language, movement of human body, or part of relating to the hands, arms, and face and head. So here we can find the two different types of hand gesture recognition, but we will concentrate we have concentrated mostly our research on static hand gesture recognition, also that dynamic here. Yeah. So dynamic, it is nothing but a video signal processing. Okay, static is image processing analysis. Okay, so we will concentrate our work on static gesture recognition. There are we will show here there are few different application of gesture. Applications are are, for example, it is shown here that virtual reality purpose and also the sign language recognition purpose. Okay, so look that what is the virtual reality. As you have seen that different TV channel in the TV channel, when that they are reading the newses, okay, they don't have time to read that slide one by one. What they are doing, they are putting only gesture by handing next slides or the next window will come and show that what are the different ways. So what is that application? Look that this lady is putting or giving that next or giving a gesture to come to the next slides or the next page. What is the news channel in front of the TV? So there will be a camera. This camera will capture the image of gesture image, so that these gestures will support to the, so these gesture, okay, so this gesture are particularly the capture of the gesture image. So after the recognition, it's showing that this is instructions is coming to the show in the next slides. So in this way, this is for sign language recognition for a deaf and dumb person who is unable to, okay, who is unable to speak, unable to listen your voice, so that they need some sign language, that one. So these types of in sign language of based on the gesture, okay, if I'll print that what they want to show or what we want to share with him or her, so correspondingly that the words will be displayed and the language will be recognized. Okay, so in the next application we can find out the human robot interaction, so that whatever we want to show that we want to share with the robot, or a robot can be applied for a specific purpose by using the gestures. For games also, or a games, the controlling of different events in games, events of games can be controlled using the gesture. Okay, So this is one other important applications of the gesture. One is the smart home interactive control. Okay, to turn on your I mean to enter to home, you just put off. I mean put your hand on a particular screen or a which can accept your gesture, and automatically the door can be opened. Similarly, to turn on light, fans, TVs, or different accessories, you can use the gestures. So therefore, the smart home interactive control, we can use the gestures. These are the different pose of the gestures. Now, the second question comes, these are the different, a lot of application can be done in the gestures. Or one other applications also can be for if you want to build an autonomous vehicle. Okay, if you want to build a driverless vehicle or unmanned vehicle, okay, so here there will not be any driver. So there also the gestures will be used. How? Because there will be number of cameras in front of the car. Okay, so when the persons or when the car moving through the road, that all the images of road will be captured by the cameras of the car, and there will be a processing. The analysis will be done by these types of image or videos, and based on that, the decision will be taken by the computers or by the processors which is given to the car. There are persons or roads, or the road is completely empty, the car can move here, or what will be the speed of the car, what will be the directions of the car, everything can be controlled by these types of gestures. But here look that the gestures are dynamic gestures, because when persons are when it is moved from the one side to another side, the car automatically stopped. If there are the traffic signal, the car automatically will be stopped. So these are all are applications of the gestures. Okay. Now the question is that what are the devices will be used for the hand computer interactions? Look here, we can use that for a gesture recognition. We can use for the color marker. Okay, from these colors, when you capture the images, automatically this yellow color, which is the one marker is wearing by the user, when it is captured the whole image, this the yellow mark will define the gesture's position. Okay, based on that, if I'll do the image processing. So LED on finger, when there will be the LED put on the finger, okay, LED will be set up on the finger. So based on the LED image or a finger images, we can define that what will be the gesture code by analysis of the image processing. So data globes can be applied for the hand computer interaction. Okay, where because of data globes, the person can easily capture the images for the further processing. What are the other things what are the other devices can be used? The lip motion can be used. Okay, here look at here, the fingers can be used for the gestures. Webcam, simply of similar, most popular used for the gesture, it is webcam. Okay, because it's a easily available and low cost. by the by capturing of the images, then process it, and the gestures can be recognized. The depth sensors is the another sensors, which is very suitable for application of the gestures also, because apart from the two dimension, it gives another dimension which is called the depth. Depth defines that how much distance from your finger from the computers. Okay, how much distance from the computers from the finger from this. Okay, or your hand is how much distance, what is the depth, or the user's face, how much distance. So for the depth sensors is suitable because it is easily to recognize your hand part, because depth sensors, if these persons are given the posture or a gesture, because of hand is in front of this face, so easily can be this hand can be segregated or segmented easily compared to its face. Okay, so it's a called of a depth sensor. So we'll define that. We have done our experiment in lab. We have applied the 3 different data sets. One is that the database 1, which is called the sign language datasets, Danish datasets, standard datasets. Datasets 2, which consist of 1000 images. Okay, for 25 static hand gestures. 40 samples are taken from each class. And dataset 1 consists of 25 sign languages. Okay, and dataset 2 and 3 are, this is called the dataset 1. Okay, this is the this is dataset 1. Okay, and datasets 2 and 3 has developed in our lab, where the 24 hand languages with that 10 volunteers have taken. Okay, most of them are not familiar with the gesture recognition. Okay, now because if they will familiar, what will happen? They intentionally gives the either a good data or bad data, so that they have not informed for what is gesture recognition. They are not informed about it. So here, this is the different hand gesture parts are captured for static hand gestures. These are also that the static hand gestures part are captured from 24 ASL or uniform background it is taken. And here we have in our lab also we have taken this is a non-uniform background. Okay, for all the different characters. Look that the lot of characters, for example, this is for O and 0 are very similar. So these are the lot of characters are very similar. Okay. Okay. So dataset 3 contains of 2400 of color images. Okay, each images of thread 320 cross 240 of size of images. Okay, dataset 2 comprises of 2400 of grayscale images, but it is one the color images. Okay. Now we described about that the gesture recognition application. We described about that what are the devices and as you know that lectures also that gesture recognition or the nonlinearly separable pattern for nonlinearly separable pattern classification, for example, of gesture recognition. People have used generally for MLBVP, RBA, support vector machine, etc. But these are the features are nothing but the features what we captured, nothing but a handcrafted features. But handcrafted features are a lot of limitations because the handcrafted features are user defined. You don't know that which will be the specific or which will be the best features to capture it, or what will be the best features by which it can recognize the things. So therefore, we'll go for the deep features. Particularly, we'll apply here the convolutional neural network based features. Okay. So the deep features still had challenges because if you extract the deep features, we need a large number of data sets that applied for the training. So to overcome these problems for the large data set problems, we'll apply the transfer learning methods for the feature extraction. And as it is known as the deep features, the dimensions of the features are very, very high. We'll apply here the principal compound analysis technique. Okay. So first we'll extract that based on the features, which is features is completely dissimilar, which is completely dissimilar compared to the other features. That will be the principal component. Based on that principal component, we'll see the other features variance, which is completely orthogonal to the other features. Or orthogonal means which is orthogonal represents the dissimilarities of the features. Okay. So first, which is completely orthogonal to the compared to the other features, that is all the that is the dissimilar features that will consider the first principal component. Based on that first principal component, we will rank the other features completely based on their dissimilarities. Okay, which is more than 99.9% dissimilarities of the features. We will consider only that type of features, or which is orthogonal to the principal component. The other features we will consider that features, which is not orthogonal to that features we will not consider. So based on that, we can reduce the dimensions of the features. So finally, for 36 gesture poses, that means 26 for alphabet and 10 for digit recognition, using the support vector machine classifier will happen. Okay. So finally, towards this objective, we'll see that what are the methods we have applied. So first, database one, we have applied for the massive university datasets where the 36 ASL classes are there. Number of subjects are 5. Total samples are taken 2,550. So these are the challenges are illumination, hand shape, scale, and rotation. All the challenges we did not to apply any. So rotations, scale, rotation, illumination, shape of hand, similarities between the gesture poses. Okay, so that M, look here, the poses of M and N. This is for poses of M, this is poses for N. This is very, very similar look. But challenges are to particularly classify these types of patterns to be classified properly. So look here, very interesting. So these are the challenges of illumination, hand shape, scale, rotation, etc. We need not to apply any pre-processing if I apply the deep learning in our method, deep features separately. We'll directly fit to the data to the convolutional neural network and try to extract the deep features. Look that only we have applied for image resizing because every images should be in the same size. And after that, this input image or train image, we have applied a pre-trained AlexNet. AlexNet is a network, already established net, convolutional neural network that we have seen in the last class. The same trained AlexNet we have applied to this input image there and the extracted information. Okay, that whatever the input image is applied here in the pre-trained AlexNet, and after application of the pre-trained AlexNet, pre-trained means the AlexNet already trained. So after the input image, when it is applied to the pre-trained AlexNet, that means that this trained data will be fine-tuned, and from the fine-tune, the AlexNet, we can extract the features, and these extracted features will be input to the principal component analysis, okay, which is nothing but a dimensions will be reduced by the principal component analysis, and then we'll use the support vector machine as a classifier. Now one can ask the question that why we'll apply the support vector machine classifier separately, though the CNN itself has a classifier, softmax layer. Yes, true that we can use the softmax layer, but the problem is that the two problems. One is that softmax layer only of is nothing but a threshold of it. The classifier is not that much of strong. First point. Second point, the dimensions of the data here is very high. To reduce the dimension, we'll apply the features extraction, using the principal component analysis, PCA technique, to reduce the dimension. Then because of we need to apply a best classifier, we have applied the support vector machine as a classifier for the determination of the hand gesture, for the gesture. So this is for more detailed diagram for the pre-trained CNN. Architectures of the AlexNet. Okay, we can find out this is for convolution and pooling layer 1. This is convolution pooling layer 2. This is convolution pooling layer 3, and this is convolution pooling layer 4. This is the structure, that similar architecture we have already read in we have already seen in the first lecture, and from here we can apply the fully connected net. So this is for fully connected layer 6, fully connected layer 7, and fully connected layer of 8. Okay. So 8th layer, 7th layer, 6th layer. Okay. In this way, output is a layer also. We have used that. But this softmax layer we are not using for the classification, but for feature extractions, for deep feature extractions, we are using the extracted information from the FC8, and that will be the applied for the features. So here I have taken for the gesture of 2, pose 2. This is the feature map, what we can extract. From the feature map, I can see easily, okay, that what will be the visualization of the features. I mean, we can visualize the different features. So here, the feature dimensions we have used the PCA based technique, reduces the storage of space of training. Training algorithm may be faster. This is the advantage of the principal component analysis technique. And that PCA technique used to reduce the dimensions of the deep features, then applied these deep features, which is 99.99% are for feature analysis, which is, what is this? This is for orthogonalities, not redundant, that features we have, or a variance, which is from the principal component is 99.99%, which is not orthogonal to the original principal component, that features will be taken for the texture extractions. Finally, the support vector machine is well known. 1 against all multi-class support vector machines are taken. This is for optimal hyperplane. From this one, from this is the +1 and this maybe is the -1. All the data support vector machines should be in such a way it will be classified. The margin from all the data will be outside of this margin, so that the maximum, this margin will be maximum and the patterns will be separated out correctly. Okay. Now for the testing, we have used the two different methods. One is called leave one subject out method, or a cross validation. Leave one subject out cross validation test. So that means one subject samples will be used for the testing and rest of the subjects will be used for the training. So first iteration, S1 is used for the testing and S2 to S5 will be used for the training. In the second iteration, the S2 is used for the testing and S1, S3, S4 and S5 will be used for the training. In this way, it is tested. And what is the other method to test? Another method to test is hold out CV. So 80-20. So 80 will be used for the training samples and 20 will be used for the testing samples. Okay. So in this way, two different methods are applied for the performance analysis. And we have tested, we have all the different pre-trained model we have tested. And we have seen that leave one subject out cross validation test and hold out cross validation test, both the cases, our proposed, that means AlexNet 6 fully connected layer of AlexNet plus of principal component analysis shows the better performance compared to the others. If you look here, it is diagrammatically, bar diagrammatically it is shown for all the subjects, test subjects, the performance will be better. If I take the individually with the AlexNet using and also the principal component analysis. Okay. But look here, another interesting for comparison, it's showing that ASL and ASL digit recognition and alphabet, both the things, it is showing the better performance compared to the only AlexNet if I apply. This is for applied for the confusion matrix. Okay. And for all the classes, it is shown here for alphabet recognition. And it is shown that confusion matrix. Okay. Now look, the challenges are 0 and O. Challenges are 2 and V. Both are very, very similar. Look here. Challenges are 6 and W. So these are the main challenges, or these are the main few are the main gestures that is overlapped with each other. So, but still, these proposed methods it is based on the deep learning or a convolutional neural network or a AlexNet and the PCA, that still for these cases also it performs better, because we are applying the deep features here. Means every information from that, all the images are captured properly. Now here, also compared to earlier methods, and it is shown the better performance for all the cases. Okay. So here, this is one type of application For gesture recognition, it is shown. The lot of applications we have done in our lab, lot of varieties of deep learning techniques applications. We have only for one on specific areas, we have shown one application, how to extract the deep features from the data. You can also apply in your applications also. Okay. So here the deep features is applied, and that deep features are applied particularly using the transfer learning. So two important learn things around is that we have learned that one is the deep features, another is the transfer learning, how to use the network for the transfer learning. Okay. Now, second areas of application we'll see today's class is that video processing. One is the human action recognition for application of deep learning on video processing, particularly we concentrate on human action recognition. First, we'll see that what is human action recognition. Human action recognition is the procedure to detect the behavioral changes of human beings. Thus, it can also be used to detect the abnormality of the scenes for surveillance application. That means some persons are fighting to each other. So that type of human, some persons are, rushing towards something. Some persons are kept something in a secure places. So all our things are, so from if I'm able to detect by using the cameras, so all are these abnormalities or abnormal behavior of the human. Okay, if I want to recognize, that's called a human action recognitions. So it includes the motion characteristics human body of human body present in the temporal domain. Now, question is there are very few similar terms people are using in the cases of artificial intelligence. One is the action recognition, one is the activity recognition, another is the event recognition. Now, in this slide, we want to distinguish all the things. Now, in the action, we need to know that the person is walking, person is fighting, or a number of persons are fighting, or a person is running, jogging, etc. When you talk about the activity, the person is talking on the phone, person is drinking tea, the person is swimming. Okay, all these are the activities. Event. So an event means like a soccer game or a cricket, or there is a party, or something is, there is a meeting on. These types of event can be determined. Okay. Now we can able to distinguish what is action, what is activity, what is event. Now, this is very interesting thing. So we look here. This is the what when we'll do the different application, or when we'll apply deep learning in the different areas, or a pattern recognition technique or a machine learning techniques. What type of images are required? When we'll see that the y-axis showing that longer time scale, y-axis showing the higher resolution. Okay, so that when we will talk about the activity recognition, what we have seen just now, the activity recognition, that means is a talking of phone, drinking. That means something is that event is going on. Some is a part of event is going on. So we don't need that time of higher resolution. But when we talk about the tracking of a particular person or a path, we need higher resolution. Now it's a resolution important. When we talk about the action recognition, Is there any action or not? Is the person is fighting? I mean, something is going on. So it's a called of action recognition. What type of action? When you classify, then it's a called of an action classification. When which person is involved for this action? So that is a pose estimation, or using that the silhouette, we can determine what the person of actions also, or which persons involved in the actions. So here the resolution of images is important also, based on their analysis, which type of analysis you need to do. Okay. Now we can find out from these slides that level of video understanding. So human action recognition, object level understanding means location of persons and objects. Okay. So there are, look here, there are level of video and its corresponding the parts of the action, what you need to know. So if you need to know the object level, what exactly the object is, what we need to know, the location of the person and its object. If a person is running, so I need to track his path. Okay. Or you need to determine in a soccer, or in a playing, during the playing of a soccer or football, you need to find that, you need to trace the path, the football, where the football is. So that means you need to trace we need to trace the football trajectories. Okay. So then, or you need to track the football, because our important during the football match, our importance is on the football, where exactly the ball is. So you need to track the football path. So this tracking level of understanding, we need to track the object. Okay. So the object level understanding, then tracking level understanding, we need to object trajectory, and pose level understanding. What is the human body parts? Means that what exactly the human, which pose it is doing, what type of action it is giving. Okay. And finally, the activation. So recognition of human activities and events. So what type of activities is going on. So these are the all are nothing but a action recognitions. Now, so till time we have covered the basic about that, the action recognitions. Now our objective is to see that what is the real time human action recognition, how to do the real time, or why we will apply for the real time human action recognition. So here an example it is given. So it is an indoor of control room. So in a particular secure place. Okay. For what we are doing, for example, a big building. Okay, very important for government or some organizations. So we want the building should be secure properly. So every corner the surveillance cameras are there, every places, and these surveillance cameras are connected to the main central server, and the persons is is sitting in front of that one and try to locate that every moment from the different sides of the cameras. But 24/7, it is very difficult for this person to notice all the cameras for the 24/7. Therefore, even in the night, this person is sleeping, unable to detect that is there some abnormal events occurring. So therefore, we need an automatic system. Thus, it can recognize the persons. Something unusual happens, okay, in the outdoor environment. So therefore, we need the real-time human action recognitions. Here it is shown that we'll discuss that sequentially now. Here it is shown that single human action, multiple human action, and the person object interaction. We can see that, okay, we'll see that sequentially one by one all the things. What are the types of actions? So when there is a single person involved for the action, it is called a single human action. When there are multiple persons are there for an event, so it's called the multiple human interaction. For example, handshaking, fighting, boxing. Okay, when the person object interaction. Okay, some persons are kept, something is a very in a secure zone, some bags are kept that may be a dangerous. So we need to detect that immediately, and what is kept in that secure zone. So these are the different types of actions. I look on that individual's actions now. Now here for the single humans actions here. Single persons, no interactions behavior. Now here the persons are suspicious persons are marked, okay, as a yellow elliptical shape, because these persons are moving and leaving the bus. Even is staying in the bus terminal but leaving the number of times the bus. So what we have to do, I have to recognize the persons, or need to track the persons, every persons. Now here it is a single human, it is because of it is a single human person, so it is a single human detection for a longer period. So you need to detect it. When there is a multiple person, look that in the pedestrian, their number of persons are crosswalk the path. So we need to detect also these types of actions. So it's a very dangerous, because every traffic or every places that the traffic persons cannot be possible to stay. So therefore, if there is there is a camera, if there are cameras and that automatic detection systems are there, and automatically the alarm will be ringing on, and this is maybe dangerous for the persons for the cross at this stage, if I'll dangerous for the pedestrian if I'll cross the path. Okay. So this is another this is a person vehicle interaction or person object interaction. Here look that one person is rushing or running behind a vehicle. So that may be a dangerous. So these types of events can be easily incorporated for the in the traffic, so that will saves the lives of the human. Okay. So other actions, maybe the person's facility or location interaction. Look that someone left the item in a secure zone. So that the identification or a detection of the things is very important by using the object or act or a action recognitions, maybe that is very be fruitful for the determination that if some persons are kept something in a secure zone. So we have seen that different types of areas where we can apply. So I can divide that some application in broadly. One is the activity recognition is essential for surveillance application. Monitor the suspicious activities in the real-time reactions, for example, fighting, stealing, etc. Currently, surveillance systems are the main recordings. And for the surveillance systems, if we apply the determinations of the actions also, it's a very fruitful for the surveillance applications. And another applications also automatic tele-rehabilitation. Means that for rehabilitation purpose, the actions can be detected by the cameras or the processors, and all the things will be shared to the places where rehabilitations are required. And occupational therapies also we can apply for the action recognition. Intelligent assisted living or home monitorings can be applied. Look at the daily activity recognitions, fine-grained action recognitions also, and interactive action recognition. We can also apply the human action recognitions. Now here, other applications in a crowd, or event analysis we can do. Okay, in a crowd, the persons are fighting. First, persons are loitering here and there. Now here there is a riot that can be detected easily, and crowd congestions in a particular place. If it is a crowd congestions, we can determine. For example, here, due to the COVID, if there is a crowd, you can easily determine by using the action recognition, because that during this situation, there will not be any gathering. The persons, number of persons or more than 30-40% should not gather. So that type of event, we can analyze by the action recognitions. Another important applications may be action recognition, sport play analysis, analyzing the play and deducing the actions of the play. So that for the cricket, we can, based on the umpire's actions, we can easily see that, we can easily determine what happens. It is out, it is 4, 6, by, leg by, etc. All the events can be determined. So unconstant video search, if you want to search from that events, from the Google image or something, or retrieve, so you can easily do from the action itself. Now for these actions, so these are the all different types of application of the action recognition we have seen. For these types of actions, what are the challenges can be seen? The challenges are mostly for action recognition, the moving background, because it's a video, the background is always changing. The background, someone is very clean, someone there is a tree, someone the persons are in the pedestrians of all the things, all the persons are moving there, pedestrians are moving there in the background. It's called the occlusions. Okay, so this is the problems of background. There are the problems also the viewpoints, moving cameras. If there are the moving cameras, the cameras also moving, the persons also moving. That also is very difficult to that also or we need to handle it, these types of challenges. Challenges also there, the actor movement variations. When each person has his own style of executing an activity, for example, stretching his hands. Okay, so who will stretch his hands? How long it will stay? And person will stay this stretched hands. Okay, so the behavior of the or a movement of the persons also depends on that. So these are the challenges of the human action recognition. Now we'll see that some important techniques for human action recognition is a deep learning based techniques. So it is a convolutional neural network for human action recognition. We'll see that 3D CNN, okay, three-dimensional convolutional neural network. We have seen the two-dimensional. Here we will see that three-dimensional convolutional neural network. Classification using deep features, though we have seen that based on the gesture recognition, we have seen deep features. Here also we'll see multi-stream network for the human action recognition. We'll see. Also, we'll see the sequential learning based approach. So these are the four different approach for using the deep learning till today's RIS technique applied for different recognition purpose. Today we will describe for in the towards the direction of the human action recognitions. Okay, but obviously you can apply for these techniques for other applications in your applications. Okay, now look first the 3D CNN network. So what is 3D CNN? 2D convolution we have already seen that one. We have already seen that in the image, if there is a kernel will be convoluted with the image, the 3x3 image. If it is the 3x3 kernel size, so 3x3 that pixel, and it will be convoluted and will generate one convoluted output. Then this kernel will move towards all directions of the images and will get the convoluted output in individual positions. Okay, that is called the 2D convolution. When we talked about the 3D convolutions, so there are requirement of the three-dimensional. That means we require not only one image, we require the number of image sequences. Okay, so it's a called of a video. When there are the images are in different time frame, or the frames of images are in different times, if you gathered it makes a forms a video. Video is nothing but a three-dimensional. So that's why it is given the temporal point at different. It is assume it is a T1, it is a T2, it was T3, it is T4 time. Okay, so all the different times, if I arrange the frame it like this, it will generate, it will make the using the kernel, make the convolution, you'll get the convoluted output. Okay, so this is the same 3D kernel, or you can use another way for that 3D kernel for the convolutional. Okay, and you'll get the output for the using the 3D convolutions. Okay, am I clear to all of you? Okay, so it's a now we'll see that 3D CNN network. Okay, so that 3D CNN network means that extractions of the CNN extractions of the multiple features from the contiguous frames. So these are the when we convoluted from the frames, the output will be convoluted output. Okay, so this is the temporal dimension as you have seen the previously. Then make the convolution and will get the convoluted output. So extracts the multiple features from contiguous frames. Multiple 3D convolution can be applied to the contiguous frames for multiple features. As in previous figures, this is shown in the different color images. All 6 sets of connection do not share the resulting the 2 different images share the weights that it forms the 2 different feature maps as you have seen in the last classes. So it is shown in the network architecture way, so that it is the kernel, it is convoluted here with the CNN and it will move from one place to another place. You'll get the one feature map. This is all the 3D CNN network it is shown here. Okay, so this is the convolutional layer, convolution 2, convolution 3. In this way, this is fully connected network is there. And we are using of 3x3x3 filters. Okay. Am I audible to all of you? Am I audible to all of you?
Yes, sir.
Yeah. Is the screen is sharing? I mean, shifting?
Yes, sir.
Okay, okay. Because my it is showing that screen sharing is paused. That's why I'm asking. Okay, fine. Now we'll talk about the 3D CNN network. Now it is the input. When we talked about the 3D CNN network, if you look that this is the time frame, the temporal zone it is showing. Now here we'll apply the 3D CNN network. It's a very crucial nowadays. 3D CNN network with the transfer learning. Now this is the transfer learning. This is the network which already trained. After that, the network informations is or the network parameters are transferred to that network during the testing. Okay, then the fully connected layer and the things, the classifications will be done. So it is the concepts of the transfer learning. So from this 3D CNN, we can generate the activation map, frames from the input videos, feature learned after the layer 1, feature learned after layer 2, feature learned after the layer 3. At different layer, we can extract the different features. Now next, we'll see that as you have seen here, the first in 3D CNN is over. And second one, we'll see the classification with the deep features. Then we'll see the multi-stream and sequential learning. So classification using the deep features. Now, this is the data sets. Feature extraction using the deep model. So it is the image frame. We have extracted the features using the pre-trained CNN model, as you have seen for the gesture recognition, and then use for the hybrid model for the classification. The similar things what we have seen for the gesture recognition. Okay, So you can use for the one that is different. We have applied there for support vector machine only, but we can also apply the hybrid classifier. Here the k nearest neighbor classifier and support vector machine both are hybridized here for the classification of the activity of action. Okay. Now we can also see there are the, as you have seen, the deep features already I have described in more detail in the gesture recognition node. Therefore, I'll come to that mode one, the multi-stream network. Multi-stream means, look here, the two streams. One stream is spatial stream it is given, another stream is temporal stream it is given. You can add the other stream also. Okay, you can add the depth information stream or other things. More stream added, better information it should represent in the videos. So we have applied for the single frame here and the multi-frame with the optical flow, that when there will be a movement of something, there will be the optical flow. That information using that temporal information is added here. And finally, it will be added and the score will be generated. Okay. Now for the optical flow, that means it is a time informations, moving of hand, okay, moving of something, that optical flow generation, how that convolutional neural network forms that different optical flow information it is shown here using the convolutional network. Now we can add the two stream network. One is the spatial CNN, another is the motion based CNN. Okay, add it, and we can add as a more CNN features, convolutional neural network features, to append that whole information. Okay, that CNN, that features you can add, but these features you can give it to the input of the any classifiers. Okay, this is the one type of two-stream network. Here, the another type of two-stream network, it is shown. Special stream, it is shown in the one stream, and other two net is concatenated, motion net and temporal streams here, and then fused it all the informations. This is the one type of, another type of two-stream network. This is also used for the different of video processing techniques. Now here, that what I'm going to discuss here, you can apply in your own method, in your own application, by using of different types of network. Okay. Now, in the last what we have discussed, that in the convolutional neural network for human accent recognition, we have described the 3D CNN, we have described the deep features, we have described the multi-stream network. Now we will describe the sequential learning network. Particularly, sequential learning network is based on the LSTM technique. LSTM stands for long short-term memory. Long short-term memory network. It is a very, very crucial sense of recent techniques, because all the video processing in a particular frame depend on the previous frame and also the future frames. Mostly the previous frames. Because whenever you will see the, or if you will enjoy the TV, if you suddenly come in a particular movies at a particular point, you will find that this is nothing but events. It depends on a particular image or a particular event is based on the previous events. So therefore, in similarly, when you apply the convolutional neural network to recognize for a particular action, it should depend on the previous frames. To store the information from the previous frames, we'll apply here the long short-term memory networks. In short, it is called the LSTM. It's nothing but a recursive neural network, okay, which can learn the long-term dependency. That means which will be the LSTM networks, there will be a memory. Is a big changes happens in the convolutional neural network. If there is, it is shown in the experiment, if there is no memory in the previous loop, the performance degraded. If there is memory, or the previous events are captured or able to store the information the previously what happens, the performance will be improved a lot. So the objective of the LSTM network or long short-term memory network, not only the present information, also the previous information should gather for determination of a specific action. Okay, so therefore, apart from the video data, the LSTM also is added here to get the previous informations apart from the CNN. LSTM is also added here to gather the previous information. After that, use the fully connected neural network and softmax layer for the classification. Okay. Now we'll see that how LSTM. It is nothing but a recurrent neural network, as I have told. So recurrent shows that it should have the one feedback loop. That means the informations will be shared from the one frame to other frame. Okay. So networks with loops then. So therefore there will be a loop is required. Okay. So loop allows the information will pass from the one network to the another one, as you have seen in the recurrent neural network. The same information. That means LSTM is nothing but a recurrent neural network which can share the information from the previous, for the previous frames of the videos also to determine the current frame. So therefore, it will be a long-term dependency for recurrent neural network. There are the long-term dependency. Here the HT terms of dependency, but here it is not the very long-term dependency. Here the few previous frames are dependencies are there.
Excuse me, sir.
Okay, so that it's a maybe the current frame depends on the just previous frames. Okay, so this is the LSTM details. So obviously there is the carry of CT-1, that current frame depends on previous frame. Okay, so here the FT, the generate cycle, this is the LSTM details, and LSTM is how it works. Depends on the weight vectors and bias also. Okay, this is nothing but the sigma is a function, okay, multiplied with the WF HT-1, as you have seen in the neural network. Similarly, it is same at, this is the function, activation function with vector multiplied with the bias. Okay, this is the HT1 and XT1, and this is the CT-1. Okay, that can be predicted. So finally, the CT depends on the final CT depends on the CT tilde cap. So in this way, I can generate the output and also the HT from the. So LSTM depends on the previous frames. Okay. So previous frames, the two information is the CT-1 and HT-1. Two information will be captured and it generates the current frame status. Okay. So these are the, so therefore what we have observed that for video processing, we require the previous information, memory, to determine the current information. Okay. So these are the action frames. As you have seen, there are the number of actions frames are there. We need not to process all the frames. Okay. If I'll take the few important frames, then you can gather the previous frames automatically by LSTM. By LSTM, then it is a very, less time requirement, as well as in terms of the process also very fruitful. So all frames are not required here. We need to get the only few frames looked at. I have taken only few frames, one frame from here, another frame from here, and another frame from here, and I can get the whole frame videos information from these three frames. Okay. So these are the action frames. Yes, ma'am. Okay, that's why I'm asking, madam. That's why again I'll share. Again I'll share it. Okay, okay, madam. That's why I'm asking only you to you. Now it is okay. Okay, now I'll see. Madam, is it okay?
Now it is okay, sir.
Okay. That's why at the time I was asking you. Okay.
Thank you, sir.
Now, if I look at the LSTM, again, I'll come back because of PPTs. There is a problem that the sequential and learning through the LSTM, we have seen that long terms, that recurrent neural network and long-term dependencies. LSTM is explicitly designed to avoid the long-term dependency. That means LSTM depends only the previous frames. Okay, so not the recurrent neural network, all the frames are dependent. So from here, I can generate that current frame from, let's say, previous frames using the LSTM technique. So here also I can generate the output functions, and corresponding to generate the current frame, I need to generate that FT also. Here also that I can generate the IT by using the W, weight vectors, and bias. Okay. So in this way, for the current frame CT, I can generate the current frame from its CT minus 1 only. Okay. So from the output, so for current frame HT and CT, I can generate the based on the weight vectors and the previous frames, weight vectors, bias, and previous frames, I can generate it. So for examples of action frames, when we will recognize the actions, I need not to take all the frames at a time. I can take only the few frames based on its importance, and other frames are automatically can be extracted or can be generated by its a few frames. For example, I have taken of a first frame. I can take of the second frame like this. I can take the third frames from this first, second, and third. From its first, second, and third frame, I can generate all the frames. Okay. So action frames to CNN, if you look that, so for action recognition, so from all the frames, I can take only the few frames to determine the action recognitions. Okay, so therefore, we'll get the two advantage. First advantage I'll get, I need not to process all the frames at a time. Second advantage I'll get, the obviously the time will be, or computationally it will be saved. Now, if I'll use the pre-trained convolutional neural network, for example, AlexNet, GoogleNet, or VGGNet. Okay, so for fine-tuning, these frames can be used. These action frames for the training can be used for the pre-trained CNN network. For example, we can use the AlexNet, we can use the VGGNet, we can use the other any nets, for example, of GoogleNet, okay, for determination of or extractions of the features. And these are the actions can be taken as the fine-tune the things for the fine-tuned. Okay, and from here we can extract the features. Okay, so these are the extract the features, or you can classify the models by using the AlexNet or GoogleNet. So here it is very, very interesting in these slides. We can see that for action recognition, how the LSTM is used for the for the multi-stream network. Here is the two-stream network. I have LSTM is used. This is the first stream. This is the second stream network. So therefore, we need to use the bi-LSTM network. Bi means two different LSTM. We can use the M number of LSTMs node here. Look, that green node showing that forward layer, and pink node is showing the backward layer. So from the forward layer, that for the current frames, we can gather the information about the previous frames. For the backward LSTM network, we can gather the future frames of the current frames. So therefore, from one frame, we can gather the information of the previous frame. We can gather the information of the future frame. Both the previous frame and future frame informations, okay, will be merged to generate the output for the particular node. All the nodes are output will be connected and use the softmax layer to determine the actions of a particular frame. So this is the concepts of the bi-LSTM network. Look, that for any video processing application, you can use for these types of network. Okay. Now another network we'll see, it is called the sequential learning through the LSTM network. This is also applied for the video processing. So video processing, all the videos here, we can see that spatial optical data organization, that means video will be applied here. Okay, sequentially for RGB data, motion trajectory, optical flow data, video segmentation data. Okay, all the data will be applied. And this will be sequentially will be learned. This is for RGB data will be learned here. and the spatial optical data will be learned here, and then the informations will be merged here and apply for the recurrent neural network or LSTM network, and then learning. So this is the another way for the LSTM network to learn. So all the different models that we are discussing here for the video processing or computer vision applications. Now I'll come there in our application. When you talked about the action recognition, look, the three important actions: walking, jogging, and running. These important patterns are very similar, but we need to distinguish, we need to differentiate these three important actions. Now we can apply the projected plane concept. The projected plane means in the XY direction. XY direction, that means XY front view direction, XT side view direction, YT top view direction. Okay. Now, if I go for that any front view, side view, or top view direction, we can differentiate their views. When you will go for the top view direction to distinguish of these three patterns or these two frames from the top view, I can differentiate, distinguish. If I take the 2-3 frames, I can easily distinguish from it's a top view. So this is the top view. Okay, this is the top view for one. For top view for for the walking. Okay, maybe the side view, maybe the front view. Will be the front view like this. So if you look, the distinguish between all the frames, that if you go for the XT and YT projected planes from here, so projected planes from the X direction, okay, and this is the projected planes from walking for projected plane from X direction and projected plane for the Y direction. Okay, if I look that Y direction means XT means side view and YT means is the top view. Okay, so if I do for the projected plane means side view and top view. This is for side view, this is for top view. I can easily distinguish for all the classes. So this is for walking, this is for this is for walking, this is for jogging, this is for running. So correspondingly, that it can be distinguished easily when you talk the XT and top view. But for our visualization also very difficult to when you see that which frame the persons are, what actions are going on. For similar actions, therefore, if the actions are taken from its projected planes, then it is better to classify the patterns. Okay, so therefore, that for projected plane representation, similar action can be easily distinguishable. So that concept we have published one paper based on that this concept in the projected plane concept in our labs. So this is the algorithms we have developed in our lab for the projected plane concept. The similar concept that is there in the XT direction or YT directions to differentiate different projected plane to different actions of the persons. Now, what is transfer learning to? Okay, what is transfer learning for to project the planes? Now, transfer learning, the CNN requires for the large training data sets. Otherwise there will be a overfitting problem. So therefore, we can use for the transfer learning using the AlexNet through the 3D projected planes. AlexNet is the 5 convolutional layers and 3 fully connected layers. In the last 3 layers can be replaced by the manual. So that in the projected planes, we can apply the transfer learning concepts. Okay. So transfer learning means, as I have told that the pre-trained network is there. So pre-trained maybe network, maybe the AlexNet or maybe GoogleNet or maybe VGGNet. That pre-trained network, when we will train our few frames of the action frames, train it by action frame, and we will get. So this train is nothing but use it for fine tuning. For fine tuning purpose, we will get the knowledge will be transferred. From the AlexNet, we will make one model which is called the trained model. Okay. So here, what is from the AlexNet, and that knowledge will be completely transferred and will make a trained model, and this trained model used for the classification or feature extraction, whatever you want to apply it. Now, this 3-stream network, okay, the top view, side view, and front view is used, and with the transfer learning in use for the classification. Look here, we have transferred it all the different projected planes. This is published in the one conference here. Okay, so here all the projected planes, and in this these papers are awarded in the best paper in the conference. And here in the informations transferred to here and added, and finally classification code will be added and find the results. So here the main concept to distinguish the 3 complex or 3 very, very similar data, similar action. One is the running, jogging, and walking. And use the top view, side view, and front view data. And the information will be transferred and added it, and final recognition has been done. Okay. Now another paper will show here, or published work will show, which is published in RTP Transaction on emerging topics in computer intelligence in 2020. A 2-stream sequential network for human action recognitions. So we have discussed about the multi-stream concept. Now we can see here the 2-stream, how the 2-stream can be used here. So it is feature extraction and the sequential learning. Also will inform that depth information and safe informations. So the two information I'll add here, one is depth information, another is the safe informations. Then the action will be recognized here. Okay, the methodologies, what we have given the name is HARDEPT, human action recognition with the depth information. Note that here the depth information we are not using as a depth camera, but from frame itself we generate the depth information from the action frame itself. So this is the block diagram of our method. This is action video, and this is the frame level features, and this is the sequential learning features, and finally the scores are fused. Okay, here the safe information with the depth history image, and then it is the overfitting handling, and then finally the score will be fused for the recognition of the final recognitions. So this method is called the HARDEPT, human action recognition, the sequential learning used through the DB data balancing. Okay, it is a depth-based LSTM network with the depth history image. Now, this is the pre-trained CNN network. Okay, we have used for the ImageNet, large-scale ImageNet dataset. This is also a net. Okay, so using the AlexNet's model are used for the share the information or a transfer learning. Okay, so extracted features from here, we have got the 1000 dimensions. Okay, so this is the sequential information we got. So it is a 1000 dimensions are extracted. Then we got the sequential learning by LSTM network, and we got the fully connected and softmax layer. This is for one sequential learning methods, and another one. So two-stream network. Another, this is for sequential learning. Another is the depth history image. So depth history image is taken from the DHAZNet depth history images. And finally, the data augmentation. This is the depth in. That means the depth information is here. Sequential information of frames is here. Now the data augmentation and transfer learning has been done, and then that we got the fully connected and softmax layer, and finally there will be a fusion for recognition scores. So this is the whole proposition what we have made in the IEEE transaction paper for our recent techniques, okay, for human action recognitions. So here for human action recognition paradigm, we added in these cases the depth information apart from the sequential informations. Depth information is the added informations to here, where it is used for removal of the background background subtractions, and for all the information which is close to the cameras is possible to the segregated. So extra additional information is added to that for the action classifications. Using so that for we have used also DHAZNet for it. And finally, this is the DHAZNet architectures, and we have got the depth history image of output of the using the HARDEPT. Then transfer learning using the AlexNet, as I have told, the AlexNet is used for the transfer learning. Okay, that convolutional layer, there are the different convolutional layers used. Layer 2, 3, 4 to 5 convolutional layers are used, and then 3 fully connected layers are used. and corresponding channels are given. That means total 1000 dimensions feature vectors we got from the from the fully connected networks, before the fully connected neural networks. Okay, so here we got the in these cases, look here, there are convolutional layer, the convolutional layer with the filter size, and convolutional layer is used the rectified linear unit, and norm I'll show that max pooling layer uses, not that average pooling layer. Here the max pooling layer used, and filter size is used of 11 cross 11. For each filter, we got the one feature. Stride is used 4 cross 4. That means after the 4, kernel, or there will be shift of 4 different of kernel size, similar to kernel size image size. And finally, we'll got the after the using the filter size of 11 cross 11, we'll get of a 96 of different number of channels. Okay, max pooling layer is used to reduce the dimensions of the layers, or to reduce the dimensions of the parameters. So in this way, 5 convolutional neural networks are used, 5 convolutional layers are used, followed by the 3 different fully connected neural networks, and followed by the softmax layer, and then finally the classification. Okay. So if I make of more, the things are more in compact, I can write that depth history image with the resize of input layer and with the use of data augmentation. That means that from one images we can generate the multiple number of images, followed by the transferred learning. If you add that fully connected layer, softmax layer, and classification, then action recognition will be done. So in these cases, so what are the different types of data augmentation can be done here? If I look that here, the data augmentation from the depth image we have done here. So data augmentation is here, that X translation, Y translation did, the rotation and reflections. All that means of the X translations, the random shifting of -5 cross 5 pixels. So we'll generate from 1 frame to number of frames by X translation. Similarly, for Y translation, rotation and reflections, we can generate number of frames. So from here, for the transfer learning, as we require the more number of data from that, from training data, we can generate the number of training data by using the data augmentations. So that data augmentation techniques to increase the number of samples internally when the training data is very less. The network will look a single image as the different image for each loop through specific data recognition. So that this is the procedure what we have used for the data augmentation for the properly learn or properly transfer learning, used for the transfer learning as you have shown here. And then use for these augmented data or a generated number of data, we can apply for the, this is the, we can apply for the transfer learning. This is the data augmentation technique it is showing using the depth history images we can see this is for if you do that, A is showing the X translation. This is the something is shift in the translating in the X direction. BY is showing the Y directions of shifting. Okay, this direction of shifting, and here it is this directions of shifting. So it is the X directions of shifting, Y directions of the shifting. So it is the random reflections we got. Okay, so the objective of the data augmentation to generate the number of data for training of for properly train the network. So these are the results we have achieved from the for the transactions, and we found that for there are the 3 different data sets we have applied for the KTH data sets, UCF sports data sets, and JHMD data sets. And this is the shown, it is called the ROC graph, region of convergence graph, more towards of these corners, showing the best performance. So look that this is the proposed method showing the ROC curves are showing the best performance of our technique. Towards this direction showing the best performance. Okay, false positive and true positive rate, if I do that towards of it, is the best performance. So this is the paper what we have published in the IEEE transactions in the last year for the action recognition batch. Okay, so in the conclusion, we can say that throughout this lecture, we have seen the number of data throughout this lecture. We have observed the number of methods how we'll apply the deep learning techniques for the classification or recognition of patterns. Or in turn, we can say that for image processing, computer vision application, or a video processing applications, how the convolutional neural network, which is one type of deep learning in terms, one type of machine learning methods, are used for the pattern classification or recognition purpose. We have seen that the varieties using the varieties of the techniques we have seen here. Okay, so these are the few papers what we have published in our lab based on the convolutional neural network mostly, or based on the deep learning techniques. These are the few papers in the domain of based on the in the domain of hand gesture recognition and action recognitions are only shown. But our group is working over varieties of applications with a number of sponsored projects we are handling. So that's why we are working on the different various applications on the particularly on the domain of the machine learning and the deep learning techniques, or artificial intelligence technique in the domain of the machine intelligence techniques of varieties of applications. Okay, we are doing the different. Our lab is doing also the involved with the different real-time projects. Okay, in the show that in terms of a human computer interaction, in terms of a human brain interactions, or in terms of a computer to computer interactions, all the things are we are doing real-time development. Our lab is involved with this one. These are the few publications you can see, and a lot of publications you can go for the if you see that our Google Scholars publication list, you can find that more detailed publication list. Okay, thank you all. If you have any question, I am ready to answer it. Please. Is there, if you have any question, please ask your question. Is there any question?
Sir,
Thank you.
Sir?
Is there any question? Please.
sir, one of the participants asked that can you use PSNE instead of PCA for feature extraction?
In feature extraction, instead of PCA, what is that?
PSNE.
Not clear. That. P?
SNE.
Okay. So that you can apply for the feature reduction the number of methods. There are methods of F ratios, Fisher's ratios. There are methods of principal component analysis, or other methods are there. But we have chosen for that one because, as you know, that the other techniques are applied for the, for example, F ratios. What we have shown, probably the other methods, other things also, other method techniques. Each method's objective is different. For F ratios, the objective is that how to differentiate the features, how to the features are discriminated from each other. When the according to the importance for each feature, how efficient the clusters are discriminated to each other. For example, if I'll show that here, there are the number of features here, maybe that 5 features are there. So 1, 2, 3, 4, 5. So objective of any feature reduction technique is that out of 5 features, I need to take, or I need to select of that features which is important for the classifications. When we talked about the F ratio based technique or other techniques, for example, for the F ratio techniques, we'll talk that how the one feature, first feature, is responsible to clusterize different classes, assuming that we are having to classify the 3 classes. So first feature is responsible to distinguish the 3 classes of C1, C2, of C3 is like this. But when I take individually the features number 2, they may be clusterized. They may be clusterized like this. Okay, like of. Look here, this is C1, C2, C3. So that means the patterns are far away, clusters are far away to each other compared to this one, where this is the distance. Here the distance increase between the 2 clusters. Okay, and also the cluster size also shrink. Clusters are small in size compared to this size. So from whenever we want to classify, after this you will take the class. So if I'll take the feature number 2, that is more efficient compared to the feature number 1. So obviously when I'll select the feature 1, obviously when I'll select the first feature, I'll select the feature 2 compared to the feature 1. Okay, so that one, so in this way the F ratio is selecting the features. For example, when we talked about the principal component analysis, so it's basically choosing based on its similarity. Similarity based. When the features are how much close to each other. If I represent, for example, if I want to take off recognize of a pattern of A and distinguish the characters of A and or to classify the patterns of A and B, look that A and B, the 2 patterns. Now I am taking here the 3 features. One feature is the length. One feature is length. Another feature, length is to height, length height ratio. Okay. Another feature I am taking here, assuming that size or a shape. Okay. Now look that if I take length and length is to height ratio, okay, these both the features are representing very, very similar information. Certain, not very similar information, but obviously there is a overlap information. Whereas the shape is completely generates that shape of the A and B. Okay. So therefore, if I'll take off a length and height is a one feature, and shape maybe I'll take shape is another feature compared to the length is same features. So PCA basically determines the how the close relation among these features. What is the similarities among the features? So that by using the PCA technique, we will try to find out what will be the exact dissimilar features. Okay, so therefore I want to say here, so every feature reduction technique, for example, PCA, Pressure, or other techniques, there are having some important characteristics to apply. And that characteristics should be fit to your application. Then only we will apply that technique. Okay. So therefore, in this way, we need to apply for the feature reduction. In our cases, we have applied PCA because of the redundant informations are generated. To remove the redundant information, we have applied the PCA here for the gesture recognition. Is it clear to you? Am I clear?
Yes, sir. Sir,
Is there any other
queries,
question?
sir. There is no queries, sir.
There are?
No queries, sir.
Okay. Thank you. So thank you all. If there are any question or any information, you can directly send me mail. I'll try to reply.
Thank you, sir. Thank you for your wonderful session. Your session has given us a very good information and it's very informative, sir, and it's very excellent, sir. And thank you for teaching us topics which will be helpful to our research. And even in the doubts clarification section also, you have taught us very nicely, sir, and very clearly. Thank you, sir. Thank you so much. And it's our privilege to have you as a resource person today, sir. We are from bottom of my heart. I really thank you, sir.
Okay.
I thank all the participants for your wonderful support. And tomorrow's session starts sharply at 10 o'clock. Thank you. Thank you once again, sir.
Thank you all for your nice attention. Okay, thank you all. So I am closing my session now.
Sir, they are asking for your mail ID, sir.
It is given in the very first slides. Yes, you can find out.
Okay, sir.
Okay, thank you all. I am leaving the session now.
Okay, sir. Thank you, sir.
Thank you very much.